हाँ जी. So good morning everyone. How are you children? Good morning. Good morning. Good morning. Good morning. Good morning. What happened? Good morning. Good morning. Good morning. So audible, visible, everything all right? Yeah, I'm fine. Thank you. I have doubt regarding subject. Put your doubt, what problem you are facing. So let's start. So we are in between of plasma membrane or cell membrane. We discussed some part yesterday and some part we are continuing today. So cell membrane. And in last class, what the last line I wrote, I am writing that word also, that sentence also. I wrote a line that the quasi plasma membrane have a quasi fluid structure. Plasma or cell membrane, same thing. Plasma membrane have a quasi fluid structure. Now a question arises, what is the meaning of quasi fluid? You can say something it will remain solid and liquid, complete liquid. You can say like honey like. Got the idea? Jelly like somehow. More liquid side of jelly like. Honey like you can say it is better. Quasi fluid structure plasma membrane have. And this quasi fluid nature is due to phospholipid bilayer. It is in continuity of the last class, quasi fluid nature. So any student who joined today, don't worry. When you will come in the campus or you can go to YouTube, it is better. You will find the study class. Got the idea? So quasi fluid nature is due to lipid bilayer. Lipid bilayer ensure the quasi fluid nature of the plasma membrane. Lipid bilayer. Now, due to fluid nature, how many properties possible in plasma membrane? So, due to fluid nature, of plasma membrane, in short I am writing PM, what are possible? So one thing I am writing, cell growth possible. Second, cell division possible. Here in animal cell division. These help in cell division. Right. So you can write another way, not write due to, you write here fluid nature of plasma membrane help in, so you will understand it better, connect it better. So fluid nature of the plasma membrane help in cell growth, cell division, third function cell secretion, fourth function formation of intercellular junction. What is intercellular junction? Zoology sir will teach you in animal tissue. Intercellular junction and endocytosis. exocytosis, etc. Endocytosis is of two possible type, phagocytosis and another one is pinocytosis. So phagocytosis is also called cell eating and pinocytosis is also called cell drinking. So these all are possible due to quasi-fluid nature of the plasma membrane. So let me once again tell what I told in this particular slide. So in this slide, I just continued with which one? Plasma membrane. I will say about cholesterol, don't worry. So continuing the plasma membrane, and what I told in the plasma membrane, कि plasma membrane have a quasi-fluid structure, means it looking like a fluid, honey. This quasi-fluid nature is due to lipid bilayer. Who is ensuring the quasi-fluid nature? It is phospholipid bilayer. Now, better to write complete phospholipid bilayer. Phospholipid bilayer. Fluid nature help in how many function? Growth of the cell. It help in cell division. It help in secretion of any material from cell. It help in formation of intercellular junction. What is this? Zoology sir will tell you when they will touch the animal tissue. It is endocytosis. It is helping in endocytosis. Endocytosis means taking anything inside the cell. If any cell going to take any solid material inside, it is called phagocytosis. Any liquid material inside, it is called pinocytosis. Removing anything out of the cell is called exocytosis. So secretion occur by exocytosis. Got the idea? So these are the some of the function ensured due to fluid nature of the plasma membrane. Now in last class, in very last, I asked a question regarding my school time. I hope you understand about that. The question is there, right? So what questions I told? What question I told? Ki suppose that this is amoeba. Assume, you make any structure, it become amoeba. It is a regular structure. So what you will find here, it is nucleus. And I told ki when, I am just once again repeating the question so you can connect with me better. I told in the yesterday class ki when I was student like you in my first year itself, when my sir was teaching, he told about amoeba, ki amoeba present in fresh water. First thing he told. And inside the amoeba, always water is entering in your body. So how amoeba manage this excess of water? So these amoeba make a vacuole. That vacuole is called contractile vacuole. So whatever the excess water entering into the amoeba is going to store in the contractile vacuole. But question arises, contractile vacuole, how much water will store? It become too big. Every time continuous throughout 24-hour water is coming inside the cell. So what happened? Time to time these contractile vacuole came in contact of the plasma membrane. And when it came in close of the plasma membrane, what happened? Plasma membrane break. And what water enter, that water go out. Through the broken plasma membrane. Got the idea? So that time I told a question arises in my mind. Ki sir is saying ki if these contractile vacuole hit the plasma membrane break, water go out. So if plasma membrane break and water go out, then why not water came inside the cell? Water also can come, na? Why it is happening like this? That time it was a question of my mind. Got the idea? Later on, when I studied more, what I find, it is water will not able to enter inside. The reason is what? Quasi-fluid nature of the plasma membrane. Fluid nature of the plasma membrane. Plasma membrane is a fluid. Now I am giving you an example. You will understand better. Wait a minute. Fluid nature of the plasma membrane is behind it. How? I am telling you, take a stick. Take a stick. Go near the river or a pond and beat the water. Break the water. Can you break the water? As long as a stick will hit the water, water will separate. Agree? As well as a stick hit the water, from that area, water will separate as long as the area taken by the stick. As you remove the stick from the water surface, who will rejoin? Who will rejoin? Got the idea? Water will rejoin. Got the idea? So due to fluid nature, what happened? Plasma membrane breaking. As water went out, what happened? Who joined once again? Plasma membrane rejoined immediately. So there is no space to come in the water. At a given moment of time, what happened? Suppose that with force water is going from this side to that side. So at the same moment of time, who can't come? Water can't come. So as water go out, who sealed once again? Plasma membrane get resealed, because it is like water. You take a knife and try to write your name on honey. Can you write your name on honey? As you move ahead on the next alphabet, initial what you cut is merged. Getting the things or not? So such kind of property present in the plasma membrane. Understand the idea? Is it clear in the mind? And one more line, very beautiful line written in the NCERT. Lateral movement of protein in lipid bilayer. I will draw once again the diagram, don't worry. I will tell about cholesterol also, what function done by protein also. I will say you, don't worry. Got the idea? So lateral movement of protein in lipid bilayer is due to fluid nature of the membrane. Because lateral movement is not possible in solid. Lateral movement is not possible in solid. Are you getting the idea? Let me explain it. Why lateral movement is not possible in solid? Lateral movement is only possible in which one? Lateral movement is only possible in liquid. Let me tell you how. Suppose that this is a nail and this is a solid wall. It is not a screen. You think like it is the brick wall. This board is a brick wall. And I am taking a hammer and I am penetrating this nail inside the wall. But I penetrated this nail here. After 1 minute, I feel I placed the nail at a wrong place. Actually, I want this nails here. Can I drag it like this? After penetrating in the wall, can I drag the nail like this and can I came here, shift it here? Is it possible for me? It is not possible for me. Because this movement is called lateral movement. And this nail is inside a solid. So in solid, who is not possible? Lateral movement is not possible. Got the idea? Is it clear in the mind? Is it all right? So solid don't ensure lateral movement. Clear? Now, because plasma membrane is fluid type of nature, now I am telling you, take a jar and in that jar you place around 1-2 kg honey and then take a stick there. Can you drag the stick in honey like this? Yes. Or in water like this? Yes. it is possible. This is called which movement? Lateral movement. Got the idea? Anything moving, see what I am doing right now is lateral movement. This marker, pen, doing which movement right now? Lateral movement. So this lateral movement is possible due to which one? Quasi-fluid nature of the plasma membrane. Got the idea? Is it clear in the mind? You got the things? Right? Okay. So protein is moving in the lipid bilayer due to quasi-fluid nature. Now I am going to talk about transport across the cell membrane. Transport across the cell membrane. And for that, once again, I am drawing the structure of plasma membrane, then you will understand it better. So two type of transport occur. Let me first deal the flow chart, then I will tell you through the diagram. Two type of transport occur across through the membrane. One is called passive transport and another is active transport. So passive transport occur toward the gradient. What is toward the gradient? From higher concentration to lower concentration. It occurs toward the gradient. If we talk about active transport, it occurs against the gradient. What is the meaning of against the gradient? From lower concentration to higher concentration. Higher concentration. So if we talk about passive transport, this passive transport is of further two types. Passive transport occur by further two methods. One is called simple diffusion. Another one is called facilitated diffusion. Simple diffusion and facilitated diffusion. First you draw the flow chart, then I will explain everything. Don't worry about it. Right? So simple diffusion across the membrane occur through lipid bilayer. Lipid bilayer. Facilitated diffusion occur through carrier protein. Got the idea? So in passive transport, no ATP required. ATP oblique energy required. In active transport, ATP oblique, ATP is a coin of energy, energy required. Got the idea? And these active transport occur through pump protein. Which is a type of carrier protein. Now I am going to draw the diagram and I will explain all the things I have written here. who is responsible for simple diffusion, who is responsible for facilitated diffusion, who is responsible for active transport. Getting the things or not? Don't worry about it. I will draw the diagram and I will explain it. Done? Over? Noted? Two minutes. Okay, take your time. Right, now we are moving ahead. See, so this is the phospholipid bilayer. This phospholipid bilayer is behind the fluid nature of the plasma membrane. Plasma membrane have quasi-fluid structure due to this phospholipid bilayer. Now, in this phospholipid bilayer, which form the fluid component, in between, in a mosaic-like fashion, here and there, some protein molecules are embedded. So these are protein molecule. Later on, I am making other lipid bilayers here. These are what? Lipid bilayer. Got the idea? Another protein I am making. This is also a protein. Right? Further, I am making lipid bilayer. So what you are finding? Who is uniformly present? Lipid bilayer. It is making a continuous layer, and in that lipid bilayer, here and there, who is there? Proteins are present. Some protein is also present here like this. It is peripheral or extrinsic protein. Suppose that some protein embedded up to here, embedded up to here. It is intrinsic protein. Here it is peripheral protein, or here assume some proteins are there, some peripheral proteins. Getting the things or not? Who are in superficially embedded is called peripheral or extrinsic protein. Who are deeply penetrated, this one or this one, is called intrinsic protein. That protein who is from one side of membrane to other side of membrane. Such type of intrinsic protein is called transmembrane protein. This is transmembrane protein. Transmembrane protein is present in entire length of the entire thickness of membrane. Present in entire thickness of membrane. Got the idea? Understand the idea? These are peripheral protein. For your understanding, I am writing peripheral protein. Now one student asking about cholesterol, so I am making here cholesterol also. In between lipid bilayer, in some places like this, these are cholesterol are present. And this one is lipid bilayer. So this is the overall which one? Plasma membrane. Got the idea? Plasma membrane. Clear? Now, if we talk about, suppose that it is outside of cell. and here it is inside of cell. You think like na, here it is cell, it is plasma membrane, it is outside and it is inside. Inside the fluid present is called cytosol, and outside the fluid present is called extracellular fluid. And in between barrier is there, that is plasma membrane, which is a selectively permeable membrane. Here fluid is there, this fluid is called extracellular fluid, here fluid is there, that fluid is called cytosol. Now how anything moving from one side to another side across the membrane, this is the membrane, and how anything moving across the membrane. Are you getting the idea? Assume this is plasma membrane, how anything moving from one side to another side of the membrane. So suppose that I am explaining first, suppose that it is non-polar substances. Non-polar substances. Got the idea? It is another example, hydrophobic substances. Another example what? Hydrophobic substances. As you know the name, hydro means water, phobia means hate. So such substances who is hydrophobic. Can you tell me any example of non-polar substances? Can you tell me any example of non-polar substances? I am writing O2, I am writing N2. These are polar or non-polar? Gases. Got the idea? Is it? Right? CO2. These all gases are which kind of materials? Non-polar substances. Even you can say about what are the hydrophobic substances. Everyone moving from more to less. More means suppose that this substances is higher outside, in more concentration outside, more here. You see, I am just putting some star. Number of a star is more outside and number of a star is less inside. So we will say it is high concentration and we will say here it is present in low concentration. So these non-polar substances and hydrophobic substances moving across the membrane through lipid bilayer. Because lipid bilayer not object them to cross. It is phospholipid, it is also hydrophobic. Getting the things or not? So these lipid is also, phospholipid is also hydrophobic, this is also hydrophobic. So hydrophobic easily pass across the membrane. So when these substances move across the membrane in such a way, it is called simple diffusion. So who cross the membrane through lipid bilayer? When simple diffusion occur. In simple diffusion, substances move from one side of membrane to other side of the membrane through lipid bilayer. I am just writing simple diffusion. During simple diffusion, substances move across the membrane through lipid bilayer. And because diffusion occur always from high concentration to low concentration, in simple diffusion no energy required. It is a type of passive transport. I already wrote. Got the idea? So I hope you understand simple diffusion. Who is moving through simple diffusion? Hydrophobic substances. Who is moving through simple diffusion? Non-polar substances. Got the idea? Isn't it? I will tell about osmosis, don't worry. Give your attention now. Now I am telling you, some particle is there, an example, polar substances. Polar substances. Another example you can take charged particle. When moving from its high concentration to low concentration, I am writing magnesium example. I am writing calcium example. Got the idea? These are the charged particle. These charged particle not entertained by lipid bilayer. Lipid bilayer are saying, I hate you. I will not allow you to cross. You can't cross through me. So you just try to understand, suppose that this is lipid bilayer and suppose that from here and it is protein. It is what? Protein. Got the idea? Carrier protein. If suppose that calcium want to cross through lipid bilayer, they are telling, I hate you, I don't allow you to go. I don't like you. So calcium cannot cross the lipid bilayer. Got the idea? And it cannot go to other part of the membrane through lipid bilayer. It is a charged particle. So who hate the charged particle? Lipid bilayer hate the charged particle. Now who is helping calcium? These protein. These protein are saying, okay, bhai, don't worry. Lipid bilayer not allow you now. I am here for you. Don't worry. You can go to next side toward me. So what is happening? This calcium ion, this calcium is more outside, more calcium outside, and here less calcium inside. So this calcium bind with this which one? Carrier protein. And with the help of this carrier protein, it is going to the next another side. So here there is a supporter required, facilitator required. So when anything is moving from high to low concentration with the help of this carrier protein, it is called which diffusion? Facilitated diffusion. So this magnesium or calcium going from one side to another side of the membrane with the help of facilitated diffusion. Facilitated diffusion. So if I ask you what is the similarity and what is the difference in simple diffusion and facilitated diffusion? If I wrote here in a separate slide, I am writing here simple diffusion across the membrane and facilitated diffusion. Diffusion. What differences is there? So simple diffusion occur through lipid bilayer. Facilitated diffusion occur through carrier protein. Who pass through simple diffusion method? Non-polar substances, hydrophobic substances, cross the plasma membrane by this process. This process means simple diffusion process. Here who cross? Polar substances. Got the idea? Hydrophilic substances. Charged particle. Cross the plasma membrane by this process. This process means which one? Facilitated diffusion. So you got the difference between simple diffusion and facilitated diffusion. Similarity is what? Both occur from high to low concentration. Similarity I am telling. Other similarity are what? Both not require any energy. No ATP required. So what similarity between these two? Occur toward the gradient from high to low concentration both, and both don't require expenditure of energy. So you got the simple diffusion and facilitated diffusion. Here protein help not require occur through lipid bilayer, it occur through protein. Got the idea? Is it clear in the mind? Now you will ask what is osmosis, and then I will come on active transport. Osmosis. Transport of water across the membrane from one side to another side is called osmosis. Got the idea? Transport of water across the membrane is called osmosis. Understand the idea? And these osmosis also, it is a type of diffusion. Osmosis is what? It is a type of diffusion. Means in osmosis also who not require? Energy not require. Got the idea? It is occur from higher to lower concentration. Diffusion means what? It is also occur from higher to lower concentration. Got the idea? It is called osmosis. Done. Over. Now I am going to tell you about another type of transport, that is called active transport. I am coming on this diagram once again, what I drawn here. First you tell me, did you understand the difference between simple diffusion and facilitated diffusion? Did you got the idea about the osmosis? First you tell me yes or no, then I will move ahead. So what I told about simple and facilitated diffusion, listen it clearly. Someone also writing no, so listen it carefully. Most student writing yes, I understood. One or two student wrote not, listen it. Once again listen it. First difference between simple diffusion and facilitated diffusion. So bhai, this is plasma membrane. Got the idea? These you think like is lipid bilayer. In this lipid bilayer, suppose that this is a embedded carrier protein. So when anything is moving from its high to low concentration from which part? Lipid bilayer part. It is called simple diffusion. Clear? When anything is moving to another side with the help of protein part, it is called facilitated diffusion. That is clear or not clear? First thing. Means in simple diffusion across the membrane, protein, carrier protein is not involving. But in facilitated diffusion, carrier protein is involving. Got the idea? Is it clear? Is it all right? Done? Over? Up to here it is clear. Now I am telling who is going through this part. Simple diffusion. So example I told. Non-polar hydrophobic substances moving across the membrane from high to low. From which concentration to which concentration? Both the process occur from higher concentration to lower concentration. High concentration is here assume low concentration is there. Diffusion, any kind of diffusion occur from high to low concentration. Anything moving from more to less, it is called high concentration to low concentration. So when non-polar substances, when Hydrophobic substances moving from its more concentration to less concentration across the membrane, it crosses through lipid bilayer and it is called simple diffusion. Facilitated diffusion, anything moving from high to low with the help of protein is called facilitated diffusion. Who is moving with the help of protein? Who is moving with the help of protein? Charged particle, polar substances, hydrophilic substances. Getting the idea? Now, one student asking, sir, osmosis is a which type of transport? Diffusion not at all require ATP, either facilitated or simple. It is, I wrote, diffusion is a kind of passive transport. You see the flow chart. In beginning, I wrote diffusion is a type of which transport? Passive transport. Either simple diffusion or facilitated diffusion, both are passive transport, and passive transport don't require any energy or ATP. You got the idea? You got the idea? Is it clear in the mind? Is it clear in the mind? Passive transport don't require, and passive transport, I also wrote here in this slide, कि passive transport always occur from higher concentration to lower concentration. It always move from more to less. Got the idea? So osmosis, I wrote, it is a type of diffusion. When water is moving across the membrane, it is called osmosis. This is the water. Sorry, this is the membrane. Got the idea? And in this membrane, that chapter is deleted now. It is not there. This is a protein. It is called aquaporine. So water is moving with the help of, most of the water moving with the help of this aquaporine across the membrane. Got the idea? So when water is moving from higher concentration to lower concentration, from the, which one? Aquaporine mainly. Getting the things or not? Such kind of diffusion is called which one? Osmosis. Osmosis is a kind of diffusion. Are you getting the idea? Osmosis is a kind of diffusion. So I told water is moving from here to here. This phenomena is called osmosis, and it is a type of diffusion. If it is a type of diffusion, energy will require or not require? In transport of water, no energy required. Passive transport. It is a which kind of transport? Passive transport. No ATP required in water transport. Are you getting the idea? Understanding the idea? Picture came in mind or not? Now I am telling you about the active transport. Give your attention. The last one. Active transport, when anything moving against the gradient with the help of carrier protein. And this special protein is called pump protein. Pump protein is a type of carrier protein, type of transmembrane protein, and through it, who is moving? Anything moving from low concentration to high concentration. Here it is opposite. Anything moving from low to high. It is called active transport. Example of active transport is sodium, potassium pump. You will study in the nervous system, in zoology topic, in detail about sodium potassium pump. Simply I am writing the example. Sodium potassium pump is an example of active transport. It is example of which one? Active transport. So three type of things we have seen. These two are passive. Either simple diffusion, facilitated diffusion are passive process, and sodium potassium come under the example of active process. It require energy, require ATP. So you got the basic difference between simple diffusion, facilitated diffusion and active transport or not? Simple diffusion, facilitated diffusion, active transport. Did you understand the differences or not? Tell me. Active agar against the gradient, low to high. Anything when move low to high, it need energy. ATP required for that transport. And that transport is called active transport. Clear? Example of active transport is sodium potassium pump. Done. So now I am giving a introductory part of endomembranous system in one line, in 2 minutes, listen carefully, then I will leave the class, don't worry. Now I am telling you about sorry, I forget to say the function of cholesterol. One student asking cholesterol, so before endomembranous system I am saying about, it is cholesterol in the membrane. Cholesterol provide a stability to plasma membrane. How it provides a stability to plasma membrane? Let me give you an example. You know coconut, coconut oil you have seen everyone. Coconut oil everyone seen? Yeah. So coconut oil going to become more liquid in summer and it becomes solid in winter. Do you know? So lipid bilayer of the plasma membrane, major component is which one? Fatty acid. And that is also present in coconut oil. So if coconut oil melt in, become more liquid in summer and become more solid in winter, same problem may exist in plasma membrane. Na? In extreme winter, who becomes solidified? Plasma membrane is solidified. And in extreme summer, plasma membrane become more liquid. Who is telling them? Bhaiya, hold. Not become more solid, don't become more liquid. Who is creating a buffer for that? Cholesterol. Cholesterol is protecting the plasma membrane to become more liquid in which season? Becoming more liquid in which season? Summer season, and become more solid in which one? Winter season. Did you got the role of the cholesterol in the plasma membrane? Picture came, understanding came. Is it all right? Now I am telling 2 minutes you listen. I will leave it. After 2 minutes, I am just writing something. I am just giving a heading so it will help us in next class. Endomembranous system. What is this endomembranous system? So some cell organelle perform coordinated function. Some cell organelle perform coordinated function called endomembrane system. So cell organelle of coordinated function is called endomembrane system. It include, after plasma membrane, this is the next topic. It includes first cell organelle I am writing ER, endoplasmic reticulum. Second cell organelle I am writing Golgi complex. Third function I am writing lysosome. And fourth component I am writing vacuole. So these are the cell organelle whose function are coordinated. How it is coordinated, I will tell when I will teach you detail about ER, Golgi body, lysosome and vacuole. First I will give you the detailed explanation of everyone. Then I will tell you why it is a part of endomembrane system, how I am saying its function are coordinated, getting the things or not. Meanwhile, you just assume the sir told the function of ER, Golgi body, lysosome, vacuole are coordinated. Hence, these are the component of endomembrane system. Cell organelle like mitochondria, plastid, peroxisome, a new name came to you, right now? It is a microbodies. Peroxisome don't have coordinated function. Hence, it is not a part of endomembrane system. So one thing came in mind, na, who is a component of endomembrane system and who is not a component of endomembrane system. Who is why it is there, we will deal in the next class. Golgi complex, lysosome, vacuole, they are the component of endomembrane system. Peroxisome, mitochondria, plastid, they don't have coordinated function, hence it is not a component of endomembrane system. Now in exam, what I told up to today will come in the paper. Tomorrow exam is there, na? So in exam, what I told up to today will come in the paper, right? NCERT book, they mention that one student writing prokaryotic cell contains cell wall. Yeah, I also told कि prokaryotic cell have cell wall outside of cell membrane. I also told, na? Got the idea? Where we have to write, I think the app is there, our Gosalite app is there, so they will guide you. You call any in charge, they will help you out. And I will say once again, guide the student to how to write the exam. They will say, our people will say to you which app, where to write, everything they will say, don't worry. Okay? So in exam, tomorrow exam, up to this will come. What we told this week will come in the paper. So up to endomembrane system we will going to ask. Okay, ji? Okay, bye-bye. Have a good day to all of you. So you got the endomembrane system. It include what? Golgi body, lysosome, vacuole. I am sharing the screen. So this is a QR code generating. Any new student, if it is there, you just remove your mobile, take scan this QR code, entire board will come in your mobile. Entire board will come on your mobile. Got the idea? How to scan? You open the camera. You open the camera. With the help of camera, you can scan in most of the mobile. Through camera, it is going to scan now. Is it? Done? Okay, bye-bye, bye-bye. One student asking some question, I will deal you in tomorrow. Don't worry. Bye.